For this example, we want to solve the equation secant of 5 theta over 4 equals -2 on the interval from 0 to 2 pi. Again, 0 can be a possible solution, but 2 pi cannot. So this is just all of the angle measures in the first rotation around the unit circle. So this 5 theta over 4, it is going to have an impact on our solutions, but we're going to treat it, we're going to solve it as if it wasn't there, and then it's going to kind of come into play a little later. So in order to solve this, I'm going to first try and solve this using the cosine, the reciprocal function. So I'm going to use the cosine of 5 theta over 4 equals -1/2. So I'm going to try and solve this function. So we're going to kind of ignore this 5 theta over 4, and we're going to just treat it as if this was the cosine of theta. And we're going to ask ourselves, where is the cosine equal to -1/2? Well, we know that these are going to be angle measures in the third and fourth quadrant, and that's going to happen at 2 pi over 3, and also at 4 pi over 3. So when we solve this, we're going to have now two different equations that we're dealing with. So we have one equation that's dealing with the 2 pi over 3, and then another equation that's dealing with our 4 pi over 3. So because this 5 theta over 4 is here, we have to set up an equation like this. So we say 5 theta over 4 equals 2 pi over 3. But then we're going to have to also add rotations around the unit circle. So 2 pi times k. Now, the reason why we have to add full rotations around the unit circle is because what 5 theta over 4 does is it affects the number of cycles that happen between 0 and 2 pi. So because we're solving on that interval, we want to make sure we get all of the values accounted for, since this changes our period, essentially. So that's going to be one equation. And then our second equation is just going to be 5 theta over 4 equals 4 pi over 3 plus 2 pi times k, where k just represents any integer. So this is k is any integer. All right, so now we have to solve this. So we want to get theta by itself. So in order to get theta, because that's what we're solving for, we need to multiply everything by 4/5. Multiply by 4/5. Everything by 4/5. So we're going to have now theta equals, so that's 8 pi over 15. 8 pi over 15 plus 8 pi over 5k. 8 pi over 5k. And then for this one, we're going to do the same thing. Multiply by 4/5. Multiply by 4/5. Multiply by 4/5. And we're going to get theta equals 16 pi over 15 plus 8 pi over 5 times k. Now, basically what this is saying is that because this period has changed, the value that was at 2 pi over 3 originally now occurs at 8 pi over 15. So that period change made the cosine be equal to -1/2 at 8 pi over 15 rather than 2 pi over 3. And then the same is true at 16 pi over 15 rather than 4 pi over 3. Now, why do we have this value of k? So again, this value of k means that we're going to look at cycles past the first cycle, just in case any of those values fall in between this interval from 0 to 2 pi. So we have to start plugging in values of k to figure out if the sum of these numbers is going to be bigger than 2 pi. And as soon as they become bigger than 2 pi, we know that it's not going to be a solution. So if we look at when k is 0, so if k equals 0, then that just gets plugged in here and we get 8 pi over 15 plus 0, so we get 8 pi over 15. This is less than 2 pi, because if you think about what 2 pi is, 2 pi is equal to 30 pi over 15. So any angle measure that's less than 30 pi over 15 is going to be a solution. So this one works. It's not too big. Let's do the same thing here. If k is 0, we're going to get 16 pi over 15 plus 0, which is just 16 pi over 15. And again, this one is less than 30 pi over 15, so it works. What if k equals 1? So if k is 1, we're going to get 8 pi over 15 plus 8 pi over 5 times 1 is 8 pi over 5. And then we need to get a common denominator for that, so we're going to multiply by 3 on top and bottom to get 15ths, right? So we'll have 8 pi over 15 plus 24 pi over 15. When you take this sum, 8 and 24, that's going to be 32 pi over 15. 32 pi over 15 is bigger than 30 pi over 15, so this is not going to be a solution. Well, it would be a solution, but it's not one on the interval from 0 to 2 pi. So 32 pi over 15, that's too big. It's outside of the range that we're looking for. And let's do the same thing for the second one. So if k equals 1, we get 16 pi over 15 plus 8 pi over 5. So that's going to be, again, that's going to be 24 pi over 15 when we multiply and get a common denominator. So 16 pi over 15 plus 24 pi over 15. That's 40 pi over 15, which again is too big, and so that will not be a solution. Now, there's no real need to look for k values any larger, because if k equaling 1 is going to be too large, then when we multiply this value by 2, it's going to obviously be even larger, so it'll be too large. So all of our values that work, all of our solutions for this are theta equaling just these two, 8 pi over 15 and 16 pi over 15. And those are the two solutions to this equation.